continue our discussion. In the last video, we have discussed about collisions in two dimensions, and in this video, we are going to solve this example 5.12 based on that concept. So, what is this question saying? Consider the collision depicted in figure 5.10 to be between two billiard balls with equal masses m1 and m2. The first ball is called the cue, while the second ball is called the target. The billiard player wants to sink the target ball in a corner pocket, which is at an angle of theta 2, 37 degree, let's say. Assume that the collision is elastic and that friction and rotational motion are not important. Then we have to find out theta 1. Okay. Okay. This is the game about which the question is. So let's say this is our target, this is our cue ball, and let's say not this many, just one ball is here, which is target ball. So this is billiard game, and what will happen if the player hits this cue ball, okay, this cue ball with stick, and then it comes and strikes this target ball here. Let's say there is a ball here only. So, and he wants to put this ball in this pocket, let's say. And the angle, if this ball is moving along this line, and if we continue this line as a horizontal line, let's say this ball has to move with making an angle 37 degree with horizontal. Okay, let me move to the next slide with diagrams only. Okay, so here we have diagram. Let's say this is our cue ball and this is target ball. And if this cue ball is moving along this line to hit this target ball, and thereafter this target ball moves along this line to sink into this pocket, and this angle is 37 degree, which is marked as theta 2. Now, what will happen? Let's say this is body 1 and this is body 2. So what will happen now? If this ball hits the second ball at rest and the second ball moves along this direction, the first ball will also move in this direction, making some angle. Let's say this angle is theta 1 with this horizontal. So we have to find out this theta 1. How can we proceed? Let's say initial velocity of this ball 1 is u1 and initial velocity of this second ball or target ball is 0. And after collision, let's say final velocity of ball 1 is v1 and final velocity of ball 2 is v2. So there are several things given here. First of all, these two balls have same mass. So let's say the mass is m1. Okay, let me change the color of this ink. Let's say the mass is m1 equals to m2 equals to m. So we can apply one thing here, conservation of linear momentum. Okay, we should not be worried about the force imparted to this first ball. We are considering the situation when this ball starts moving and then it collides. During all this incident, there is no external net force acting on the ball. So the linear momentum will remain conserved. That is m1 u1 plus m2 u2. u2 is 0, so I'm not writing that term here. And m1 v1 plus m2 v2. This is conservation of linear momentum here. Okay. Now m1 and m2 are equal, so we can simplify this term as u1 equals to v1 plus v2. This is one thing. And second thing is given here, that the collision is elastic collision. So we have 1 by 2 m u1 square, that is kinetic energy, is going to be conserved during this incident. So 1 by 2 m1 u1 square and m1 m2 are same, so I can write m only. M u1 square plus 1 by 2 m u2 square, u2 is 0, so I am not writing that term again here. 1 by 2 m v1 square plus 1 by 2 m v2 square. So we can simplify this term further and we will get u1 square equals to v1 square plus v2 square. This is equation 2. Now, if we want to do u1 dot u1, that is if we want to do a square of this equation, so it will be LHS square equals to RHS square. So we will have U1 dot U1 equals to V1 plus V2 dot V1 plus V2. And then this will be U1 square equals to, now V1 dot V1 will be V1 square, and V1 dot V2 will be simply V1 dot V2 we have to form, and V2 dot V1 will be V2 dot V1, and then we will have V2 dot V2, that is V2 square. And we know the dot product is commutative in nature. It means V1 dot V2 and V2 dot V1, these two are equal. So we can write U1 square equals to, let me rearrange these terms, V1 square plus V2 square plus 2 V1 dot V2. And now we have already found out that U1 square equals to V1 square plus V2 square. It means we can write, instead of V1 square plus V2 square, we can write U1 square equals to U1 square plus 2 V1 dot V2. And then we will have 2 V1 dot V2 equals to 0, because these two things are same, so we can subtract U1 square from both sides and then we will get this thing. Now 2 is not 0, so 2 multiplied with something is 0 here, that is V1 dot V2. This is going to be 0, and then we can write V1 dot V2 is 0. From here we will get magnitude of V1 times magnitude of V2 cos and angle between these two vectors. And what is the angle between these two vectors? We can check it from here. Angle between V1 and V2 is theta 1 plus theta 2, which is 37 degree. So we can write cos theta 1 plus theta 2, which is 37 degree, equals to 0. And these two magnitudes are not 0, as we are considering that this ball is moving along this direction, then the first ball or the cube will also move. So if it would be a head-on collision, then the first ball will remain at rest at this position, and the second ball will start motion with the same velocity, the velocity with which the first ball hit this second ball. So here it is not happening. Here it is collision in two dimensions. Actually, the balls are moving in two different directions, so they have velocities. So they have magnitude of their velocities non-zero. So we can write these two are not 0. Then we have only one thing here, which is 0. Or we can write cos theta 1 plus 37 degree equals to 0. Or we can write cos 90 degree. Although there are several angles where cos theta is 0. But here, this angle range is between greater than 0 and less than 180 here. So we can write theta 1 equals to 90 degree minus 37 degree, and it will be 5 and 3, 53 degrees. So we have obtained the value of theta 1 now. One thing you can guess here, or you can see clearly, that in this particular scenario where two balls are of equal masses and they are going under elastic collision, and if this happens after collision, they make an angle of 90 degree, means their velocities make an angle of 90 degree to each other. So this is all up to here, and from next video we will start our discussion of previous year questions.